Welcome to Probability Video 7.2, Counting Pins. First, let's talk about what a PIN stands for. Personal Identification Number. So just so you know, it doesn't make sense to ask somebody for their PIN number because number is already the N in the acronym. All right, example 2. A PIN is made from exactly 4 symbols chosen from the 26 letters, so again we'll assume all caps, or the 10 digits, 0 through 9. All right, there's 4 parts, and the first 3 parts are really leading to the last part. All right, how many total pins are there with repetition allowed? So I could be A through Z, or it could be 0 through 9. So there's a total of 36 different symbols to choose from. And the same would occur for each of the other steps as well. So that'd just be 36 to the 4th. Same problem, no repetition allowed. Again, I can be A to Z, 0 to 9, 36. Once I choose a symbol, I can't repeat it. So 35 times 34 times 33. Okay, I'll punch out numbers for that. So for the first one, it comes out to be 1,679,616. And for the second one, it turns out to be 1,413,720. Okay, part C. How many pins are there with at least one repeated symbol? Okay, so again, I've underlined some important things: with repetition, without repetition, at least one repeated symbol. So again, for that at least one, either it's going to rain or it's not going to rain. Either you're going to have at least one symbol repeated or you're not going to have any symbols repeated. So for this problem, I go back to my diagram, the total number of ways of doing something, which actually over here was 1,679,616. And then break it down into at least one repeated or no repeated. Again, it's much easier to count the ways that things don't occur. We already did that. That was 1,413,720. So if I want to find this chunk over here, it will simply be total minus that chunk there. So at least one repetition will be total minus no repetition. Or in this case, 1,679,616 minus 1,413,720. And if we punch that out, we get 265,896. Okay, now this is really the problem that could have been asked without all this guidance along the way. If you randomly select a pin, what's the probability of getting at least one repeated symbol? So I've also boxed some other important things. How many, how many, how many, probability. And probability is just the number of successful outcomes over total. So in order to do probability, you got to know how to count. That's why so many of our examples just involve counting. All right, so the number of at least one repetition, oh, I think we got that right here. 265,896 over the total possible, I believe we did up here. 1,679,616. And for problems like this, let's agree to just go to 3 decimal places. So that would be 0.158. So 15.8% approximately. So there you have it. How to deal with problems involving repetition, no repetition, leading to probability of at least one repetition.